all around doing these problems and developing the confidence they need, and keeping some of the kids with me, helping those who need help, sending some kids who feel really confident to work with other kids, even encouraging kids who don't feel as confident to work with kids who feel very confident. Eventually what I do is I'll stop everybody and tell them, hey, let's keep an organized record. And that's when the kids now start keeping track of things. So I'll ask questions like this. I'll say, so what are some various ways how we can keep an organized record? So I'm going to do that. I'm going to demonstrate various ways how kids can keep an organized record. So here's the problem: 23 times 12. So I've got it all set up, 23 times 12. And I could be doing this with kids, or the kids can do it on their own, but I'm going to demonstrate as if I'm working with a group of kids who have been doing the problems and feel very confident. So now I'm going to lead them to a way how to keep an organized record. Okay, so here it goes. Okay, boys and girls, your group seems to be very confident with this. So I just want to see what you're doing and help you keep an organized record. So why don't you do that first? You just do the problem. So here the kids are doing the problem. So here the kids are very confident. They're just throwing these things out very quickly. So here we go. So the kids are at this point. So now I can lead them in a variety of ways to keep an organized record. So here's one way how to keep an organized record. Okay, boys and girls, let's keep an organized record here. So what would be one way how we can keep an organized record to help us figure out how to do this without using manipulatives eventually? Oh, okay, we can record partial products. So let's record everything that we get for the answer of this right here. Where did this come from? Oh, that came from multiplying 20 times 10. 20 times 10 is 200. Okay? How about this one right here? Where is this coming from? Oh, that's from multiplying 3 ones times 110. So that 3 times 110, and that's 30. Where did this come from? Oh, that's from multiplying 20 times 2, which is 40. I multiply that 20 times 2, which is 40. And this over here is 6 ones. That 3 times 2. So now I can just add these up together, and I see I have 6 ones, I have 7 tens, and I have 2 hundreds. Okay, that might be one way how one group might keep a written record. So now let's pretend like we have another group of kids who are solving the same problem, but now they're going to keep a written record differently. So boys and girls, I noticed that you've been multiplying 23 times 12, and now it's time to keep an organized record. So what would be one way for you to keep an organized record? So the kids might say, oh, I can keep an organized record by writing down everything that created this right here. I said, okay, so what created that? Oh, that's 23 times 10. 23 times 10 is 230. Okay. Now what about this part right here, this partial product? Where did that come from? That came from 23 times 2. 23 times 2 is 46. Now I add this all up to get the final answer. Okay? So that's a second way kids can keep an organized record. Another way kids can keep an organized record, again, same problem. It's by doing it this way. Okay, boys and girls, we're going to keep an organized record here. And what's one how we can keep an organized record? Oh yeah, we can keep an organized record first by saying, okay, what is the number 23 times 2? Where is that supposed to be? So 23 times 2 is down here. So how many times is 23 times 2? Is 46. Then we multiply 23 times 10, and that's up here. 23 times 10 is 230. So we add that together, and we get 276. So there's 3 different ways that kids can keep an organized record. It really doesn't matter how they keep an organized record, as long as they're keeping an organized record eventually. But this doesn't happen until the children feel very, very confident with just setting up a problem, solving it, adding like units, and getting a final answer. You don't show these things here, or you don't encourage them to keep an organized record like this until they're very confident with just solving problems using manipulatives and not worried about anything else other than just using the manipulatives and solving the problem. Once the children are keeping an organized record, or as they're keeping an organized record, you also ask for things about what patterns do you see? And so, as the kids are keeping an organized record, and as they're also solving problems before they keep an organized record, you're constantly asking them, what patterns do you see? And so, when the kids tell you patterns, all you do is record them. You can post them, you can put them up on the board, you can stop all the kids and just say, hey, someone has a pattern they want to share. So I'm just going to pretend, okay? So I'm going to a group of kids who are working on these problems, and I ask them, so what patterns do you see? So here's some patterns they might see. They might say, oh, look at this. 3 times 2 is 6, and that's the last number at the end. Okay, I might say, okay, that's pretty good. What's another pattern you see? Oh, I see that 1s times 10s makes a 10. Okay, so 1 times a 10 makes a 10. That's another pattern. What else, other patterns you see? They might say 10 times 10 makes 100. See, it doesn't really matter what patterns they see, just as long as they see patterns and they tell you patterns. They might also say that, oh, when I multiply a number, like 23 times 12, my answer is always going to be way larger than my original number. So, okay, that's another pattern. Once the kids have identified patterns, the next step is they're going to tell me a hypothesis of how they're going to solve the problem without using manipulatives. And when they do that, they're going to show me the various ways how they would do that. So for example, I'm going to go again with 23 times 12. One child might come up to me and say, hey, I have a hypothesis of how to solve 23 times 12. And I asked him, so what do you do? I said, well, first I multiply the 10s times 10s, that gives me this one. Then I'm going to multiply 1s times 10s, which gives me this partial product. Then I'm going to multiply 10s times 1s, which gives me this one. And then I'm going to multiply 3 times 2, which gives me this. Then I add it all together, and I get 276. I said, oh, really? Show me another one with the same, show me another problem, and walk me through it. So, again, I have them do this, and they tell me, well, 30 times 20 is 600. 4 times 20 is 80. 30 times 4 is 120. 4 times 4 is 16. And then all I do is add it up. And there's my answer. 34 times 24 is 816. So a child might say this to me. Another child might come up to me and say, oh, I have another way of doing this. They might say, so for example, I have 23 times 12. I do 23 times 10, which is 230. Then I do 23 times 2, which is 46. And I add it up, that's 276. I said, oh, really? So let me give you another problem. So I might have them do this one. So I'll say, well, then show me how you would multiply 38 times 24. And the child would say, well, first I would say 38 times 20. 38 times 20 is 760. Then I would multiply 38 times 4. 38 times 4 is 8 times 4 is 12. The 32. 3 times 4 is 12 plus 3 more is 15. So I multiplied 38 times 20, which gave me 760. And then I multiplied 38 times 4, which is 152. And then I add these up, I get 912. So the whole purpose is for a child to tell me the step-by-step process of what they do. Another child might come up to me and say, hey, I've got another way to do this. So, oh yeah, what do you do? I said, well, I've got 23 times 12. First I multiply 3 times 2, which is 6. 2 times 2 is 4. It's 46 because 23 times 2 is 46. And that 2 is a 10, so that's got to be a 40. I said, okay. Now what are you going to do? Now I'm going to multiply 23 times 10. 3 times 1 is 3, but that 1 is really a 10, so that 3 has to go over here because it's 30. And then 2 times 1 is really 2 tens times 1 10, which is 100, so I put that over here, so 200. So now I add it, 276. So, oh, well, let me give you another problem. I just want you to tell me what you do, okay? So again, the child's going to lead me through the process. They're going to tell me step by step what they do. They're going to say, 4 times 6 is 24. That's too many to write. I can't write 24 here, so I have to put 2 tens up here because that 3 is a 10. 3 tens times 6 ones is 18 tens, plus 2 more tens is 20 tens. Now I'm going to multiply 4 ones times 34 times 20. I'm going to multiply 4 ones times 2 tens, which is 8 tens. I'm not going to put it here because it's 8 tens. If I put the 8 here, that's going to be 8 ones. It's 8 tens. That's why I have to put the 8 there. 3 times 2 is 6, and it's tens times tens, which is hundreds, so that's 6 hundreds. And I'm going to put a 0 here to help me remember that this answer is 680, not 68. I'm going to add these up. I'm going to add like terms for ones and ones are 1, so that's 4 ones, 8 tens, 8 hundreds. So that's how I multiply. So by the time a child tells me these things, they've established a hypothesis of how to multiply a 2-digit number times a 2-digit number. Once they've stated a hypothesis to me, and it seems reasonable to me, I will give them problems now to test the hypothesis. So one group of kids came up to me and showed me this one. So I'll tell them, all right, you 4, since you came up with this hypothesis, you go work on testing your hypothesis. Where are some places where you can get problems? They might give me options. They can say, well, you can give us problems. I say, okay, that's one. What else can you do? Oh, we can get problems out of a book, or we can create our own problems. All right, so you're going to create 2-digit numbers times a 2-digit number and solve using your hypothesis. How are you going to check your answer? So the kids might say, oh, we'll check it with our calculators. Or they say, oh, we'll use our base 10 materials. And those would be their options. And they're going to then rotate responsibilities. This group of kids, again with this hypothesis, will go do the same thing. They'll go solve problems that they can get from me. They can check their answers. They can get problems from a book. They can check their answer with a calculator. They can check their answer using manipulatives of a 2-digit times a 2-digit. This group of kids will do the same thing again. They're going to get problems to test their hypothesis. They're either going to create their own problems, they can get problems from me, or they can get problems from the book. And then they're going to check their answer using manipulatives or check their answers using handheld calculators. And then they're going to rotate responsibilities. The kids will continue to test their hypothesis until they have determined that their hypothesis works. Once they come to me and are completely convinced that their hypothesis works, then I give them practice problems. Basically, the math lab approach is done. It's now time to do practice activities to check to make sure they know what they're doing. The purpose of a practice activity, again, is to help them become faster at what they do and how they do it.